Hi everyone, so now we're going to be talking about independent versus dependent probability. These are just kind of different probabilities. So an independent probability or independent events are events which are not affected by the occurrence of other events, which means that dependent probability would be events that are affected by the occurrence of other events. A good example of this would be an independent probability would be like, what's the probability that I sleep out 8 hours a night, and what's the probability that my sister sleeps 8 hours a night? Those don't really have an effect on each other, but dependent events would have an effect on each other. So what's the probability that I sleep 8 hours a night, and given that I drank a bunch of caffeine at 8 p.m. So those ones might have an effect, right? If I drink a lot of caffeine at night, then I might not sleep for 8 full hours. Whereas like me sleeping 8 hours a night and my sister sleeping 8 hours a night don't really affect one another. So in this self-check, we're going to be talking about a lot about independent events and how to determine if events are independent or dependent. And the big formula that we're going to use is this one right here. So this says that in order for events to be independent, they need to follow this equation. And this equation says the probability of A and B, where you have an event A and an event B. So the probability of A and B both occurring has to be equal to the probability of A occurring times the probability of B occurring, if they're to be independent. Dependent events don't have a particular formula attached to them, so I didn't write one down. But this one will help us understand, because if something isn't independent, then it's dependent. So let's just start going through these examples. The first example is asking us to determine if events A and B are independent or dependent. So in order to do that, we're going to use the equation that I just underlined in red. They give us a probability for A, which is 2/5, a probability for B, which is 3/4, and then a probability of A and B, which is 3/10. So what I'm going to do is replace those portions of the formula with the numbers and see if it makes sense. So we're going to start with probability of A and B, which they told us was 3/10. And then that's going to be equal to the probability of A, which we know is 2/5, times the probability of B, which is 3/4. Now what I want to do is figure out if the left side is equal to the right side. Now the left side is 3/10. I can't simplify that any further, so we're going to leave it as 3/10. But on the right side, what I can do is actually multiply those fractions. So when I multiply fractions, I multiply top, top, bottom, bottom. So 2 times 3 is 6. 5 times 4 is 20. So we need to figure out if 3/10 is equal to 6/20, which it is, because I can simplify 6/20 by dividing each chunk by 2. When I divide each chunk by 2, I end up with 3/10. So because this equation says 3/10 is equal to 3/10, that means that it makes sense, right? We know that 3/10 is equal to 3/10, and so because of the reflexive property. And so because this equation makes sense, then these events are independent. Now, if it didn't make sense, or if we got independent, I can't spell. If we got 3/10 is equal to 4/5, or 3/10 is equal to 1/2, or something that didn't make sense, the left side didn't equal the right side, then the events would be dependent. Okay, so for the second and third examples, what we're going to do is find the missing probabilities given that A and B are independent. So we already know that these things are independent, so we're going to find the missing chunks, or the chunks that I have the question marks on. I'm just going to write the formula down one more time down here. So we've got probability of A and B is equal to the probability of A times the probability of B. And they gave us the probability of A and the probability of B. We want to find the probability of A and B. So I'm going to leave the probability of A and B right here, but I'm going to replace the probability of A with what I know it is, which is 3/10. And then I'm going to replace the probability of B with 1/5, which is what it is. So to find the probability of A and B, all I have to do is multiply the fractions. So 3/10 times 1/5, when I multiply fractions, I multiply top, top, bottom, bottom. So 3 times 1 is 3. 10 times 5 is 50. 3/50ths can't be simplified, and so my final answer is 3/50ths, meaning that the probability of A and B is 3/50ths. And I can just use that formula right off the bat because they told me that the events were independent. If they didn't tell us that the events were independent, we wouldn't be able to just use the equation right off the bat. But on these examples, we already know that they're independent, so we can use this equation. So the third example is the same. We're going to assume that these events are independent, which means we can use the formula to solve for the question mark. So let me write down the formula one more time. Probability of A and B is equal to the probability of A times the probability of B. Okay, we know the probability of A is 9/20ths, so I'm going to replace that with 9/20ths. The probability of B is what we're solving for, so I'm going to leave it as probability of B, and that's what we'll solve for. And then the probability of A and B is 63 over 100. So we're going to leave it as 63 over 100 right here. Now to solve for the probability of B, what we have to do is get the probability of B by itself on one side. In order to do that, we need to move the 9/20ths. Now, two options: we can divide by 9/20ths on both sides, or we can multiply by its reciprocal, which is 20 over 9. I'm going to multiply each side by 20 over 9. This is just a tricky rule with fractions, if you remember. So multiply each side by 20 over 9. What happens is the 9 over 20 and 20 over 9 cancel each other out on the left-hand side. And then what we would be left with is that 20 over 9 times 63 over 100 is equal to the probability of B. So now all I have to do is multiply 20 over 9 and 63 over 100 to figure out what the probability of B is. So when we multiply fractions, we multiply top, top, bottom, bottom. So I'm going to do 20 times 63, which gives me 1260, big number. Then we do 9 over 100, or 9 times 100, which is 900. And then we're going to simplify that. Both of those are divisible, let's see, by 180. So I'm going to divide by 180 on both top and bottom, and I get 7 over 5. So that's the probability of B. Okay. Last question. We first have to decide if this describes an independent or dependent situation, and then find the probability. So let's read through the question. A bag contains 7 red marbles and 4 blue marbles. You randomly pick a marble, then a second marble after returning the first marble to the bag. What's the probability that both marbles are red? So the first thing we have to do is decide if these are independent events or dependent events. The way that we can do that is kind of going back to the definition of independent and dependent. So do the two events, getting one red marble and then a second red marble, have any effect on each other? This one is independent. The reason why it's independent, I'm going to start using red and blue. So we know we have 7 red marbles. 1, 2, 3, 4, 5, 6, 7. And we have 4 blue marbles. 1, 2, 3, 4. So the first event, or event A, would be me picking out 1 red marble. If I pick out 1 red marble, let's say that I pick out this red marble, the probability of me picking out that red marble would be 7 over 11. So I'm going to write probability of A is 7 over 11. The reason why I know the probability is 7 over 11 is because I want to pick a red marble, and there are 7 red marbles. So I have 7 chances to get a red marble. And then there are 11 total marbles in the bag, so that's kind of the total, meaning that the probability of me picking a red is the amount of reds divided by the total. So that's my probability. Now, what happens is if I pick a red marble out of a bag, then I only have 10 marbles left, right? So If I were to pick another one without replacing that, then yes, it would be dependent because then my total would change. But what this question is saying is that I picked that red marble out of the bag, and then I put it back in, and then I picked another one. So when I put the red marble back into the bag, I still have the same amount of marbles. In fact, I still have the same amount of red marbles. I have the same amount of blue marbles, which means that the probability of B, or the probability of me picking that second red marble, I could potentially pick the same exact red marble. And I would get 7/11 again, because there's still the same amount of total marbles in there, and there's still the same amount of red marbles in there. This is why they're considered independent events. So let's just now figure out what the probability of picking both red marbles would be. We're going to use the formula, the probability of A and B, meaning in this case, the probability of picking a red marble and then another red marble is the probability of A times the probability of B, which would be, this is what we're trying to find, the probability of A and B. We know the probability of picking the first red marble, is 7/11. Picking this second red marble is also 7/11 because remember, we put the marble back into the bag, so this total stayed the same. So when I multiply those, I get 49/121. So that's the probability of A and B. We know that those are independent because you have the same total. It's like the same bag. One did not affect the other. Now let me just explain the dependent situation in this case. If we have, so let's go back to the probability of A. We know picking one red marble, it would be 7/11. Great. Let's say that instead of putting the marble back into the bag, you just threw it away. So if I put the marble back into the bag, or if I threw the marble away, then what would happen is I would have one less marble, right? So the probability of B would then be the amount of red marbles, which would be 6, over the amount of total marbles, which is 10. So that changes a couple of things, right? So it affected, like you picking a red marble at first changed what your probability was when you picked the second red marble, for in this case. And because it changed the probability, or because it affected the outcome of the second probability, that means that those two events are dependent. So the question as it's written is independent. I just wanted to show you what could make it dependent. And there we have it, independent and dependent events.